Hello, LinkedIn Live, Facebook, Twitch, and Periscope, Facebook, of course. And good Wednesday morning. Wait, good Wednesday morning to you. All right, it's time for Frank to have some coffee, but in the meantime, I will stay hydrated. Today is something a little special. I kind of meant to do this yesterday, but due to a time constraint and less than ideal preparation, I did kind of cut the other stream short. I will pop up the chat, so if you have any questions, let me know. As you can see, I have is coming. I need to change it now. Quantum is here, right? One of the things that happened this week, actually yesterday, was that Microsoft, let's see if I can pop this here, is now in public preview. Azure Quantum is now in public preview. So in order to make this easier for me and give it a few more minutes for folks to join, let me pop in the dubstep intro, because this is going to be an episode of Impact Quantum. All right. Will my camera come back? And it does indeed. My name's Frank Lavinia, and you are listening to another episode of Impact Quantum, recorded live on February 3rd, 2021. So basically, we had not had a Impact Quantum show in a while. Shame on me. But a big part of this is the fact that I had kind of exhausted my knowledge of what I knew and what I could share. Anything beyond that, I don't think would have been responsible. So I've spent the last month or two learning and studying and getting up to speed on some more concepts, and I've been sharing that. So what really kind of kicked me into high gear was yesterday's announcement of Microsoft moving Azure Quantum from private preview into public preview. So let me give you a little bit of insight into this. I have been trying to no avail to get early access to this. And perhaps I should have tried harder, but now it doesn't matter anymore. So ultimately, what's been announced is the Azure Quantum service is in public preview, which means don't use it for production systems. But I suspect that if you are, it's 2021, and if you're doing quantum systems in production, you probably know that already. So basically, it's going to be a little bit different than what other offerings from Google or Amazon have had in terms of public cloud. But it's the idea of building out an ecosystem around quantum. Now, at first, when I heard that, I'll be honest, I was a bit skeptical. Why are you building out an ecosystem? Why are you not building out your own? But then I kind of had a moment of realization, and that this is going to be akin to building out what the ecosystem that Microsoft did with Windows and the PC, and to a certain extent also Azure and kind of Windows in the enterprise. So I think this is going to be an incredible kind of shift. It's not just about this. And if you look at this, if you're looking to try this out, at about $10 per compute hour, which isn't that bad when you're considering that to build your own quantum computer is non-trivial. To engage with a company like D-Wave, non-trivial. Let's see what the full expense chart is. Just a friendly reminder, as a member of the Microsoft MTC, I typically don't get involved in pricing discussions. Now, what's interesting is that for 0 to 1 hour of compute time, keep in mind, this isn't what you're doing. Looks like you can get 5 concurrent jobs and 0 to 1 hour for free for learning and developing purpose. What's interesting is, look at this. Quantum Monte Carlo. Look at this. 0 to 1 hour is free. 0 to 100 hours is $90 an hour. et cetera, et cetera. If you look at this, this is something that I can, I guess, now talk about FPGA quantum annealing, simulated annealing. If you go back and you look at the data driven podcast, where from November 2019, where I just had this like aha moment from the MLADS conference, that's basically what they were talking about. So that was November 2019. Here we are, February 2021. I've been sitting on this one for a while, not because I don't love my audience, but uh, because I like my job. So to that end, I want to say, and I also want to, I'll include this in the show notes if you're listening to this later on a future recording of the podcast. So for folks who are watching this live, if you don't know, I have a podcast called Impact Quantum. Go to impactquantum.com or go over to iTunes, Stitcher, Spotify, and just search for Impact Quantum. And this is a show. So I want to kickstart this show. Because a lot of interest, this kicked up a lot of dust and kicked up a lot of interest. If you notice, there's a lot more YouTube videos coming out lately about quantum computing that are more recent, and it's definitely on the rise. Guarantee you that this is on the rise. And I saw this in November 2019 as kind of coming, and then sometimes I'm right, sometimes I'm wrong. I always have this tablet PC license plate to remind me that sometimes I'm wrong about predicting the future, or I'm right just in kind of a don't quite figure out where and how it's going to manifest. But I just want to, there's a lot of news stories about this. ZDNet has a really good article on this. I think that if you look at this price chart, and I'm not selling this, obviously I work for Microsoft, they pay my mortgage. But if you kind of look at this, where's the price chart? Our pricing chart generally is can be a bit challenging, but I mean, ultimately, you have no upfront cost, so zero input into kind of experimenting with quantum computers. So if you have a problem that maybe quantum computers could solve, I mean, you're not going to do it within 1 hour of compute to kind of learn and play with it. Definitely you can do kind of get started. But I mean, if you look at that price per compute hour, I mean, 1 to 20 hours is $10 per hour. You can do this here. This FPGA simulated annealing is going to change things. It's going to, the key there is simulated. So if you're not familiar, FPGA stands for Field Programmable Gateway Architecture. I can't describe this in a way that will do it justice, but essentially it's, think of it like a hardware that can be programmed in the field. It's a bit like an EEPROM chip, if you remember those, right? So you can actually kind of alter the circuitry of the hardware, and it's a lot more flexible. So it's really blurring the line between the distinction between hardware and software. And what this is going to enable is kind of simulate a real quantum computer in such a way that you'll get enormous performance. So what the GPU did for CPUs, kind of working on CPUs, FPGA will do for GPU. So it's another level, another quantum level, if you will, of advancement. Now, I don't know enough about it to really kind of speak more eloquently than that. And unlike some other folks on the internets, if I can't talk about it intelligently, I tend not to talk about it in public. I say. So anytime I talk about something online on a stream or in a podcast, it's something I'm comfortable talking about and I know about. I kind of get it, but I'm not quite to that point where I get it entirely. So quantum Monte Carlo is basically running Monte Carlo simulations. And if you're a data scientist, you probably know what that is. It's not taking your money and going to the casinos in Monte Carlo, although that is a beautiful place. It is not getting a Monte Carlo car and driving it a quarter mile, although that is fun too. I've done that. This is about taking the Monte Carlo method of simulation and future prediction and applying a quantum algorithms to it. So there's definitely a lot of stuff here I want to talk about in the future for future episodes. So to that end, I have been mining a lot of data about quantum computing, reading a lot more books. And if you go to franksworld.com, you'll see that there's been an uptick of late of quantum computing posts. So I've actually elevated this a couple months ago on the toolbar where it says home, data science, AI, machine learning, and quantum computing, um, and also the podcast. So one of the things that I've noticed here is that there's been an uptick on this, right? So kind of these basic, right, the basic overview of what Azure Quantum is, a kind of an announcement about this, right? This Anastasia here has done a really good job on a YouTube video explaining what the math skills that are needed from quantum computing. I myself am working out my math kung fu to get better at this. IBM did a with their director of research, Dario Gil, talked about this. This here is got to be the winner of in terms of how he explains this. Um, I want to have him on the show and kind of talk about what he talks about. So if you studied computer science and you kind of know, if you think back to college, which for me is, let's just say when I was in college, the Notorious B.I.G., Tupac, and Kurt Cobain were still alive. So I had to really think back because he started talking about this state machines and all this, the unit circle, and I was like, okay. After watching it, I started clicking. Now, if you watch my other live streams, I've talked about this video before. Highly recommend it. But basically, what for me, I'm at some point, quantum computing is going to branch out into different kind of subfields and subgenres. This happens all the time, right? It happened with data science, right? Data science was this one monolithic skill that you had to have to perform in that. Now you're starting seeing people calling themselves machine learning engineers, AI engineers, data scientists, right? And obviously data engineering is as old as time, but at one point data engineering itself, you got confused with being a DBA because typically only DBAs really did it. And I think that we're kind of on the cusp of this. We're early. This is the new frontier. We are here. And with the opening of Azure Quantum to public preview, I think this is going to move the needle even further. Now, I know what you're thinking, potentially, that you're thinking that, well, Frank, you work for Microsoft, so you're just a cheerleader for them. And maybe that's true. But I will say this, is that I've heard from my customers, as well as other kind of places on the internets, as well as kind of through the grapevine, is that a lot of companies were not thinking that quantum is really ready for enterprise until Microsoft, which if you love them or you hate them, is a huge player in enterprise IT, right? It is what it is. And ultimately, now that Microsoft has, opened the gates to a preview, and it's a preview, and it's not production ready, but now you're going to see a lot of enterprise customers start scratching their chin saying, maybe we should look at this. And for you, dear listener, that is a cue for the opportunity. Right here, right now, we are witnessing the birth of a new era in computing. Is it going to be fancy and swanky? No, it's not. But if you recall, mobile wasn't really fancy and swanky when they got off the ground. Everyone thinks that the mobile era started with the first iPhone. It did. It exploded then, right? That's when it got fancy. That's when it got pretty. That's when it got, dare I say, sexy. But, BlackBerry had been doing, mobile work. I remember drooling over a Palm 7, right? And if you don't know what a Palm Pilot is, kids, look in your history books. But the Palm 7, which was the 7th iteration of the Palm Pilot, which was a little PDA, you couldn't make phone calls on it, but the Palm 7 had an integrated cell phone chip. So you were able to check emails on the go, which at one point was just darn near science fiction. It wasn't really until the iPhone came out that the world exploded. And the folks that had been playing around with mobile tech rode that wave beforehand. One of the things that I highly recommend folks look up is the Rocker. I think it's the ROCKR, and it was a joint project between Apple and Motorola, which ultimately the frustration that Steve Jobs had with that technology led to the iPhone. Why am I doing this history lesson? Because I'm trying to tell you that right now, quantum computing is hard. Right now, you have to worry about qubits and quantum physics. But at some point in the near future, that's going to be abstracted away. Guaranteed. Guaranteed that's going to be abstracted away. And that talk from this gentleman here was really kind of the embryonic moment of when this is going to be abstracted away, right? He wasn't talking about qubits. He only mentioned the qubits and their state and kind of how they can be in superposition as tangential to the purpose of this is how you would code a quantum algorithm. This is how you do it. It was all tangential. And when I saw that, I knew, one, that I could understand it. Two, it spoke to me. And three, that this is the cusp. This is, as Hunter Thompson would say, the main nerve right now is this quantum algorithms. He explained why they are orders of magnitude faster. I'm not going to lie. First time I listened to it, didn't quite get it all. But what was encouraging is that there was one concept, and it's around the 45, 50-minute mark in the video where he talks about Deutsch's oracle, that he said, if you get this part, you'll get everything. Well, for me, I got the hard part, but some of the stuff leading up to it really didn't click. But that's just the weird thing of how my brain works. But chances are, if you're watching the stream for this long and you've been following my stuff, you know my brain doesn't work quite normally. Another interesting video, and I shared this on LinkedIn earlier today, was Anastasia Marchenkova, and I apologize if I'm pronouncing that name wrong. With a name like Levine or Lavinia, I understand what it's like to have your name pronounced wrong. And she talks about how she got into quantum computing research. This is the main nerve. She's right on it. She has her finger on the pulse, whatever analogy you want to use. Definitely check out her video. There's a number of kind of explainer videos that are starting to come out. 4 things you need to know about quantum computing. This is, if you think about that hype curve and that hype train, we are definitely early in the cycle. But that doesn't mean that there's nothing there, right? There's definitely something here. And the fact that Microsoft, a trusted enterprise IT provider, is now swung open the doors. A lot of folks in those corner offices and those big enterprises are now scratching their chin, and they're now thinking, you know what? This may be ready for prime time. You know what? We should start looking at it. And right here, at this point in time, this is that moment, right? This is the time to skill up in this space. And, if you had any doubts about that, here we are. Start exploring on yourself. Start reading the books. The O'Reilly book is awesome. I hear there's a Manning book done by a couple of researchers at Microsoft in the pipeline. I haven't picked that up yet, but I will. But it's here, right? The time is now, and quantum is here. So with that, I'm happy to take any questions, and I will answer them in the best I can. Anastasia, if you're watching, definitely would love to have you on the show, either a live stream video or kind of a typical pre-recorded show that we have. I would love to have you on the show. You are formally invited. If you are anyone else in the quantum researching field, definitely would love to have you on the show, talk about quantum computing, help our listeners kind of get skilled up in this space. It's time to learn quantum. All right. So with that, I've kind of ran out of things to say. So I'm happy to take any questions. This is so what I've been doing, if you've noticed, with the exception of my Saturday live streams, I've been doing different times of day just to kind of get a feel for what is the best time to stream. I have noticed that there's definitely preferences towards lunchtime. Now, however, with my work schedule, I can't always make that happen. Having a consistent time to stream is definitely, everyone has told me that that's the way to grow, go get your message out. So I am working on that. But in the meantime, I figure, you know what? It's just best to stream. Have stuff in my head and in my heart I want to say and get out there. And I really want to do this week because of the announcements with quantum. And it's here now. So with that, I am going to get myself another cup of hot steaming coffee. It is cold here in the DC metro. We're still getting flurries, if you can believe it, which I feel bad for the kids because of all the times that they could have had like multiple snow days. It doesn't mean anything anymore. I was joking with my kids, like, you'll be telling your kids that you remember when it snowed, you got a day off from school. Now right now it doesn't mean anything, but who knows? What's going to happen when things go back to somewhat normal? Hey, Robin, how's it going? Yes, this is exciting. It is exciting. I mean, imagine if you were um, around when the transistor was developed, right? If you were, in or around, Texas Instruments or, Intel, or was it Fairchild Semiconductor? I mean, we're at that embryonic stage, maybe a year or two after that. But I mean, this is the cusp of the revolution, right? This is where, this week is going to be, in my mind, obviously a Microsoft employee, obviously a Microsoft cheerleader. Um, but in my mind, this is going to be the moment when enterprises are going to start lifting their ears and taking a serious look at this. And if you any kind of revolution in terms of technology, there's always kind of those leading kind of innovators, right? You think back to MySpace, right? MySpace was around in the early to mid 2000s, right? It's gone now, but enterprises and big companies didn't really take to it. But look at how quickly other social networks has grown. Yeah, Pinterest would be a good example, right? Twitter and Facebook kind of led the charge to make it mainstream, just as the iPhone made mobile technology mainstream. But before the iPhone, there were cell phones. There were Windows phones. Ask me how I know about those. But this was definitely, we are kind of in that. I'm not sure if we're on that iPhone moment yet. I don't think we're there. I think we're kind of at the point where, um, maybe to use the historical analogy of the transistor, I think we're like a year or two after the invention of the transistor, because at some point, and there was a really good documentary I saw on this, is that the notion of a transistor is kind of a disposable object, right? Because you could produce them in mass and so cheap. Um, it became that was kind of the aha moment, the lightning moment, if you will. And yeah, it is definitely quantum is here. It's not quantum is coming. I have to change it with the Photoshop graphics and stuff like that. But ultimately, I mean, it's here. The time is now. We're not at that iPhone moment. I would say we're probably at the late Palm, early BlackBerry moment, when mobility became far more accessible and people were just starting to see that it had impact beyond kind of its core use, right? So the core use for the Palm and the BlackBerry were enterprise users, but there was definitely a point where, people were like, you probably put games on this. You could probably watch movies on this. So I think we're at that point now. We're kind of at the Palm 7, early BlackBerry era. There will be a kind of an iPhone moment, an iPad moment that will explode everything. And we're not there yet, but we're getting there. And the best time to hop on a rocket is when before it's going thousands of miles an hour. And I think there's a unique opportunity here for data scientists, because you're already comfortable with the math, or at least tolerate the math, right? Or you even love the math, right? There's an opportunity here for folks who are in the data and AI space to kind of just add another tool in their tool belt, right? I'll use an archery example, right? Add another quiver in your, another arrow to your quiver, right? Whatever analogy you want to use, it's not that much of a stretch to get into quantum computing. Would I start teaching, learn to code with quantum qubits? Not yet. I suspect someday that will be the case, but I mean, um, ultimately, this is the time to jump on. Just pick up a book, watch a few YouTube videos. There's some really good classes on Pluralsight where they explain the concepts. Go to franksworld.com, click on the quantum computing tick or toolbar, not tick. Click on the quantum computing tab, check it out, go through the videos. I've been oscillating between kind of hard videos and easy videos. IBM has a number of videos about how to learn Qiskit, which I think I'm pronouncing it right, but that's their programming language. I don't know which programming language is going to win. Is it going to be Q Sharp? Is it going to be Qiskit? Is there going to be, there's some Python variant that's built for quantum algorithms. Not sure which one's going to win that, but that's not important right now. What's important is getting your head around the concept, getting your head around why quantum algorithms are faster, why they're better. Get your head around that first, the rest will follow. So with that, I want to say thank you. Thank you, Robin, for watching. Thank you for commenting. Thanks to everyone who's watching this live. Thanks to everyone who's watching this later. I want to wish you a great Wednesday. And remember, quantum I was going to say quantum is coming, but quantum is here. The future is now. Take it in your hands. Start learning. Whether that's YouTube, books, dusting off that old math textbook on linear algebra. The time is now to start working out, because you want to be ready. You want to be ready when those recruiters call and they say in 3 years, and they say, do you have 10 years experience in Q Sharp? The time is now. Hey, Andy, how's it going? You are welcome. Andy, my brother from another mother, co-host on Impact Quantum and Data Driven, and also cohort in our secret project called Project Ringgate. But we'll talk more about that later. I just wanted to keep the focus today on quantum computing and how we're here and we're now. And if you're not on Clubhouse, hit me up. I do have an invite I could spare. And there's actually some really good conversations on quantum computing. And I'll be honest, like one of the people on there was talking about how they read the book Quantum Computing for Everyone, which at this point is like a 2-year-old book, which is kind of crazy. But what interested me was, somebody was talking about how they read that book and how it worked for them. For me, that book actually added more confused me more than it helped. The hardbound kind of college textbook look that I got last year called Quantum Computing and Applied Approach, that spoke to me. That worked. So honestly, I could have easily kind of like, I'm not fit for this. I'm not ready for this. But you know what? I'll make a movie quote from Cars 1, right? Find a groove that works for you and stick to it, right? If you like the way Anastasia presents stuff, follow her, listen to her stuff. If you like the way, dare I say, the way that Andy and I present stuff and talk about stuff, then follow us. If you read a book that utterly inspires you, then by all means, follow that path. If you read a book that kind of makes you confused and a little bit dizzy, then you know what, put that book to the side. So for Quantum Computing for Everyone, I'm not sure I'm included in that everyone list. I mean, I don't know why that book didn't speak to me. Maybe I'll reread it after this this talk from this Microsoft researcher guy, because things are starting crystallize a little better. But the future is here, and the best time to prepare for the future isn't tomorrow, isn't next week, isn't the future itself. It's today, right now. Right? The best time would have been, yesterday. Well, since we don't have a time machine, although maybe quantum computing will help us with that. Who knows? So that's the bottom line. I want to say thank you for watching, and I will show off some more fancy motion graphics skills that I got. That's actually an interesting point. I wonder if quantum computers could help render graphics faster.